Hi everyone, we're going to do two problems here. One is a square root function, rational, no it's not rational, and we're also going to do one with rational. So the first one we're going to do is f of x equals the square root of x minus 2 and g of x equals square root of 4 minus x. And that's the first one. And then the second one we're going to do is f of x equals 1 plus 1 over x, and g of x equals 1 over x. Okay, so we got to do 4 things to these. The first one, so we're going to find f plus g of x. Then we're going to find f minus g of x. And the third thing is f times g of x. And we're also going to find f divided by g of x. And again, the main thing we're really searching for is finding the domain after we combine the two functions. So for the first one, we're going to find f, so this is a, f plus g of x, and that's going to equal my f, which is the square root of x minus 2, and my g, which is the square root of 4 minus x. Now we have the issues with the square root with the parent function, whereas this value here has to be greater than or equal to 0. So we're going to set both of these pieces inside here to be greater than or equal to 0. So we have x minus 2 is greater than or equal to 0. So x is greater than or equal to 2. And for this piece, we have 4 minus x is greater than or equal to 0, which means negative x is greater than or equal to negative 4. When you negate this, you get x, and you have to flip that, is less than or equal to 4. So the way you would write this is x is all real numbers such that x has to be greater than or equal to 2, but less than or equal to 4. That's the best way to write that. Okay? Now for the minus part, we're going to get the same thing. Basically, it's just that we have square root of x minus 2 minus square root of 4 minus x. So basically, it's the same domain, because you can set both of these to be greater than or equal to 0. So basically, it's the same domain. It's all real numbers such that x is in between 2 and 4, inclusive of both 2 and 4. Now, the next two we're going to do as times. So c is f times g of x, which just equals the square root of x minus 2 times the square root of 4 minus x. Now, algebra-wise, this is just going to be square root of x minus 2. You can put them together because they're both squares, square roots, 4 minus x. And that gives you the square root of negative x squared plus 6x minus 8. So that's just the algebra. However, when you're doing the domain, I wouldn't even look at that. I would just look at this one. It's going to be the same as before, because you're looking at this piece. Well, just look at this piece, these two pieces. So the domain's going to be the same as it was for A and B. X is in between 2 and 4 inclusive. And the last bit is the division part of x. So we're going to get the square root of x minus 2 over square root of 4 minus x. Now we still, even though it's not in the denominator, have to consider that this has to be x is greater than or equal to 2. And this one, however, since it's in the denominator, this is going to be, instead of x is less than or equal to 4, it can't equal 4, because that would make it 0. So we have to take away the negative there. It can only be less than. We already did the work in solving it. So basically it's the same, except it's x is in between 2 inclusive and excluding the 4. Okay? Now the next sets we have are f of x equals 1 plus 1 over x, and g of x equals 1 over x. So for a, we have f plus g of x. So when you add that, you get 1 plus 1 over x plus 1 over x. There's 2 of those. So that's just going to be 1 plus 2 over x. The domain, therefore, is just going to be x belongs to all real numbers. However, x cannot equal 0. And that's because you can't divide by 0 there. So for b, we have f minus g of x. And that's going to be equal to 1 plus 1 over x minus 1 over x. And that's going to be equal to 1. However, you still, even though these two cancel out, you still have to go by the first function and say that, well, x is all real numbers, but x cannot be 0, because the wouldn't make sense if you said 1 plus undefined minus undefined. So you still have to take each piece separately there. Okay. Now for c, we have times. So that's f times g of x. So that's going to be 1 plus 1 over x times 1 over x, which equals 1 over x plus 1 over x squared. Therefore, the domain is all real numbers, but x can't be 0. And for the division one, it's going to be f over g times x, which is 1 plus 1 over x divided by 1 over x. Now I'm going to simplify this with the common denominator is x. That's going to be x plus 1 over 1 over x. Now, what happens is you can cancel these two and you just get x plus 1. However, you still have to take into consideration the original, or you can't even simplify. So the domain is the same. It's all real numbers, but x cannot be 0. And these two right here are very important when we get the composition of functions and when we do the domain for that. Okay, let's see. The next set, I have one more set of this. These are going to be rationals without the square roots. Okay. No, one has a square root. Okay, thank you and have a nice day. Bye-bye.